Hello guys, welcome back. Today let's talk about root recursion. So by the end of this topic, you should be able to understand what root recursion is, and you should also be able to configure root recursion successfully. So IP packet from PC1, that is 192.168.0. That IP packet need to reach the network of 192.168.3.0. So when PC1 here forwards the packet to router A here will look at its IP routing table and search for the route for that network. So it will check the next hop and the outbound interface to forward that packet. So after that, it will forward it to this router here. Then this router here will also look at its IP routing table and find that the next hop should be .60.1.3.1. Then it forwards to that router. When router C receives that packet, it will know that that packet is the destination for that packet is within its network, its subnet. So it will forward it to the next. That is will be direct route. So that's how we are going to implement root recursion. So root recursion, like for example, let me explain now. When this guy tried to send packet to the destination of 192.168.3, its next hop will be 60.1.3.1. But in that case, for routes forwarding to work appropriately, the link must be the next hop must be directly connected to that network here. So when you look at here, this 60.1.3.1 is not directly connected to the network of 192.168.0. So for that case, I will configure root recursion. So first of all, I will tell this router here to forward that packet to this network. After that network, so it's this network that will tell router C where router network of router A here belongs. So we'll first of all we'll configure the network towards the network of that gateway. Then the next hop for that will be .2 here, that is directly connected for the direct link. Also, you configure now the network from router A here to PC3. So that's the network of 192.168.3.0, which next hop will be .60.1.3.1. So it is this network will tell this next hop where find that network. So that's actually the practical we're going to implement. So by the end of this session, PC1 here on branch 1 should be able to talk to PC3 here on the company's headquarters. Also, PC2 on this branch 2 here should be able to ping PC3 on that other network. Again, the PCs on the branch side should be able also to ping each other. So in this case, we are going to configure static routes. So we are going to configure static routes on these routes to tell the next hop and also the outbound interfaces where we can forward our traffic. So let's begin. So first of all, what we are going to do, we are going to configure the IP addresses on that device. So change the device name. So this one is router 1. So in router 1 here, so router 1 here we are going to configure two interfaces. That's gig 1 and gig 2. So interface gig 0/0/1. IP address, we are going to give it IP address of 192. Let me so that you can see it. 192.168. No, not .168. That is 60 60.1.1.1/24. That is for gig 1. Then gig 2 IP address will be 192.168.1.2/24. After that, the next thing you're going to do is quit and also come to this PC and give it IP address 192.168.1.1. The gateway will be /24.255.255.255, and our gateway will be 192.168.1.2. You apply and see if you can ping that gateway. So ping 192.168.1.2, and let's also ping 60.1. So ping 60.1.1.1. It's able to also reach that 60.1.1. After that, you also come to this this one here. You configure the IP address UTM and change the device name. So this is the internet. So internet. So like you see, this is branch. This is our headquarters. So they need to communicate through the internet. So after the end of this session, we're going to configure IPsec VPN to secure our network so that people browsing from the branch side should browse securely to our headquarters. So interface gig 0/0/1. IP address, you give it IP address of 60.1.1.2/24. Then gig 2 we are going to give IP address of that's the interface that connect to branch 2. IP address of 60.1.2.2/24. Then gig 3 that connects to the headquarters. So gig 3 IP address of 60.1.3.2/24. You quit. Also come to this other PC on the PC on branch 2. You configure IP address and the device name. This is .b. After that, interface gig 0/0/1. IP address, we're going to give it IP address of 60.1.2.1/24. Then for gig 2 we give it IP address of 192.168.2.1/24. Then you come to the PC and you assign it IP address manually. So this is 192.168.2.1. The subnet mask is /24, so 255.255.255. Our gateway will be 192.168.2.2. You apply and see if you can ping that gateway. So ping 60.1.2.1. so it's able to ping, so meaning that that link is up. So the next is now configure router C here, that's on the headquarter, and you assign the interfaces, the IP addresses. So this is router C. So interface gig 1, gig 0/0/1. I'll give you the IP address of 60.1.3.1/24, and gig 2 give it IP address of 192.168.3.2/24, and you come to this PC here and you give it IP address manually. So 192.168.3.1. then the subnet must be 255.255.255, and our gateway will be 192.168.3.2. then you apply and you ping that network of 60.1 or .3 and see if that link is up. So ping 60.1.3.2.1. so it's now able to reach that one. So the next thing we are going to do is now to configure the route so that PC1 and PC3 should be able to reach each other, and also PC3 and PC2 should be able to reach each other. They should be able to communicate. So first of all, we are going to configure route from router A here towards the network of PC3, and then we recurse it on this network of 60.1.3.0. so you come here, you quit. After you quit, you configure IP route static. We tell it the network will be now 190. First of all, let recurse it. Configure the recursion first of all. So the recursion route will be 60.1.3.0. The mask of 24. Then our next hop will be this .2 here. So we want to configure the route towards the network of 60.1.3.0, but our next hop will be 60.1.1.2. so this one here. So you come here and you give it a next hop of 60.1.1.2. After that, now we configure the route towards the PC2. So we configure the route towards this network of 192.168.3.0 because it will be able to be recursed on this network of 60.1.3.0. But for this route here of this network, the next hop will be 60.1.3.1. So you come here, IP route static 192.168.3.0/24. The next hop will configure to be 60.1.3.1.3.1. So that's how we configure the route recursion. So first of all, we want to configure from route A to the network of 192.168.3.0 where PC3 belongs. But there's no direct link between router A and the router where PC router C belongs. So first of all, for static routes to work, there must be a direct link connection for us to configure the next hop. So our next hop here is not on a direct link. So first of all, we'll configure the next hop that is directly linked to the network where we belong, the subnet where we belong. So after that, that route here will recurse to the next hop of that network where we want to reach. So you do the same. You can also come to router B here and you quit. On router B, we're also going to configure a network towards 192.168.3.0. But first of all, we recurse it on a network of 60.1.3.0. So IP route static 192.60. So the first recursion. So 60.1.3.0. Our next hop will be 60.1./24. Then the next hop will be 60.1.2.2. So then the next hop for this network here, it will be .2. So while on this router we configure destination of 60.1.3.0, but our next hop will be .2 here. So after configuring that, now we configure to the final destination. So IP route static, the destination will be 192.168.3.0/24. Our next hop for that route that has been recast will be 60.1.3.1. So we do the same. Remember, when you're configuring static route, should be a two-way. So when you configure in the other direction, you'll make sure it's bidirectional. We'll also configure it from that direction towards the opposite way. So come to this router, we configure the routes towards these two networks of the two branches. So you quit and you configure routes towards the network of PC1. So IP route static. But before we reach PC1 here, first of all, we are going to recurse it on. We're going to recurse it on its network of 60.1.0, 60.1.1.0. While the next hop we are going to select to 60.1.3.2 here. So this one here. So on PC1 here, I configure IP route static of 60.1.1.0. Mask of 24. Our next hop will be 60.1.3.2. So that's the next hop for the route that have been recast. So now we configure the final destination. So that is IP route static. The destination is 192.168.1.0. Our mask is 24. Then the next hop will be now 60.1.1.1. So that next hop is here. So we are configuring from router C to router A here. So the next hop will be .1.1 here, but it is not directly linked. So first of all, we'll configure the destination towards this network for it to recurse towards that gateway, that next hop. Also, again, you configure towards branch 2. So you come to branch 2 here. So IP route static, we are going to configure first of all the recast route, so of 60.1.2.0. the next hop /24, the next hop will be 60, the same one as we used for the other one, 60.1.3.2. Then we configure the final destination, so IP route static, the network of 192.168.2.0, mask of 24. Then our next hop will be 60.1.2.1, So that's the next hop. So that's this is the next hop here. So let's see if we can ping from this router here. Can it ping the other router? So ping network. Can you ping that gateway of 60.1.3.1? Alright, it's able to ping. So while on this router here, you can ping this other router here. So let's, while on PC1 here, can we ping for branch 1? So ping 60.1.1.1. It's able to go through, so it's able to ping that network. So meaning that this link from here to here, it's reachable. Now we want to check, can we reach from PC1, PC2 here, or PC1 here? Can it reach PC3? So you come to PC3 and you ping. First of all, let's ping the gateway of 60.1.3.1. Request timeout. So meaning that it can't reach this guy. When you're on PC1 here and you try to ping this gateway here, it cannot reach that gateway. So that's also just suggests that it cannot reach PC3. So even if you try to ping PC3 192.168.3.1, you see request timeout. So it can't reach that PC2 there. So what do you think will be the reason? So the reason is while on this PC, it doesn't know where that network here. So you come to router 3 here. Come to this our internet router here. So this internet router is where we are going to tell the networks towards that 192.168.3.0 and also the network towards the other side. So after now we configure IP root static. So we are going to tell it the network where that .3 belongs. So IP root static 192.168.1. First of all, for the branch 1.0, our /24. Then our next hop will be 60.1.1.1. Then also we configure the network towards where PC2 belongs. So that is for branch 2. So IP root static, the network will be 192.168.2.0/24. Then now our next hop will be 60.1.2.1. Then also, while you are on this internet router, we are also going to tell it the network where PC3 belongs. So configure route towards that network where PC3 is. So IP root static. So 192.168.3.0. Our next hop will be 60.1.3.1. Okay, you will not configure the mask. So /24. So now let's try and ping. Can we now reach? Okay, it's now able to reach that PC3 here. So also while on PC2 here, let's see if we can ping 192.168.1.3.1. So it's able to reach, so meaning that the routes we've configured are able to reach each other. So meaning that when router this packet is forwarding from PC1 here and get to reach router B, it will look at its routing table, and if that entry is found in the routing table, it will forward it to the next hop. So the next hop will be on this internet router here. Then the internet router will also look at it, will search its IP routing table, and if the entry is found, it will forward it to the next hop, that is 60.1.3.1. Then router C here will look at its routing table and finds that the destination where that packet should be forwarded is on the same subnet where its local IP address belongs, that is 192.168.3.2. So it finds that the destination is 192.168.3.1. It's in the same subnet where its local IP address belongs. So it will forward it directly to PC3. So that's a direct forwarding. So also we said by the end of this practical, PC2 here, PC2 here should be able to talk with PC1 here. So the branch will also be able to ping each other. So let's ping 192.168.2.1 and see. So request timeout, so meaning that they can't be able to communicate. So meaning that we've not configured the routes, this route towards these directions. So we come to router A here. You configure the routes towards where branch 2 belong. So IP route static. IP route static. So branch 2, PC2 is on network of 192.168.2.0. Then the next hop now will be for that router there. So the next hop will be, our next hop will be 60.1.1.2. Subnet mask of 24. Also you come to this side, also you make sure it's bidirectional. You also figure towards that network of PC1. So IP route static, network of 192.168.1.0, a mask of 24. Then our next hop will be 60.1.2.2. So now let's try and see if we can ping that network of 1. It's now able to go through. So if we ping that network on branch 1, I should be able to send packets successfully with 0 packet loss. So also on PC1 here, can you ping the PC on branch 2? So ping 192.168.2.1, that is on PC2 on that branch. So meaning that all the routes have been successfully configured. So guys, that's how you can configure route recursion in case the next hop is not directly connected to the network where you belong. So that's where you configure route recursion. So that's static routes. That's how you can configure static routes. But for a large scale network, static routes won't be necessary. In a large scale enterprise, you will require to configure OSPF so that they learn routes through LSS advertisements. So that one make it a lot easier rather than configuring the static routes. So thank you, and I hope you've enjoyed this video. If you have any question, just hit me in the comment section below and be able to respond as quick as possible. So thank you guys.